go for 10 here, but on a test, we have extra pencils if you need to borrow one. I would suggest starting out in pencil, because there's some, you get your first shot and then you need to make adjustments to it. So I know it's gonna be some negative something. Just as a crude first shot at it. Velocity is positive and it's 0 there. Well, let's see, my acceleration is 0 from A to B, which means my velocity is constant. From B to C, it slows down. Then C to D, it is constant again. Now notice there's sort of a sharp point right there. This is why this is my second draft, or first draft velocity, I guess. And then from D to E, it slows down and bounces back. G to H, or F to G, it is constant. G to H, it slows down. H to I, it's constant. And then, so it's sort of a step function. I would take, if this were your final answer, I would take off 1, 2, 3, 4, 5, 6, 6 or 7 points for that. So we need to smooth it out some. But let's see if this makes any sense. I have my acceleration is 0 here, since that's a flat line, my acceleration should be 0. Here my acceleration is negative, so it should be negative here. I know I have to get back to 0. Here my acceleration is negative. Here my acceleration is positive because my slope is positive. And here my slope is positive. And I know that as it stops, my acceleration, if I continue, my acceleration would be 0. So something like that. I don't quite come back down to the line because it's still positive at the end. All right, so I've done a quick, crude sketch. This is not a final result, but this is just the steps along the way. So acceleration is positive from I to J. It is positive from G to H. It's negative from D through F. And it is negative from B to C. All right, so at least this matches the plus minus 0 part. This matches the plus minus 0 part for velocity. This matches the plus minus 0 part for that. So that part, check, got that part done. Sharp corners. I got a sharp corner here, 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 lots of places, so I need to smooth that out. So instead of just drawing it like that, I'm going to put a curve to it. Same over here, put a curve to it. Trying to add a curve. Over here, same thing. I want to make sure it's differentiable is the math term. I want to make sure that there's a curve going on here, and that there's no sharp points here. And we still haven't tackled this one. My velocity is constant. Remember, this is the slope of this up here. So my velocity is constant, so this should be a straight line from A to B, because if the slope is constant, it's a straight line. Then my velocity starts getting smaller. And then it is a straight line again, so that's an attempt at a curve right there from between B and C. Then it's a straight line. Then it becomes negative again. Drew that up a little bit higher than I will end up being. It should be a straight line again from F to G. And then it becomes a, that's right, the slope is negative. And the wrong way. Let's see. Slope is negative. It starts out steeper than it ends up. Okay. And then it's flat, straight. And then it's still negative slope and becoming less so. And yeah.
You're missing a letter up top.
Am I?
Yep.
A, B, C, D, E, F, G, H. That's an H there. It's the fact that I erased it or I skipped one?
No, that you erased.
Okay, all right.
Two eyes, I guess you could say.
If I had skipped a letter, Ms. Brood would be very disappointed with me. You know, I think back on that, I'm thinking, all right, so my kindergarten teacher was, I think, just out of college, which puts her now in her 70s. What happened to her? All right, so that's a very crude sketch. This one I might try to extend a little bit, stretch out this way, just so that it's clear what's straight and what's not. If you, in a situation like this, and you can just go, see, H to I, this is straight, and just point out the straight areas. And then F to G is straight, C to D is straight, A to D is straight. But that would be a sketch of the problem.
So the line doesn't touch G at the 0, the top one?
Oh, it does, thank you. I would take off of that. Thank you for catching that. Try that again. That's A, B, C, D, E, F, G. So G was 0 and C was 0. So from A to B, now I have a chance to actually stretch this out some. From A to B, it is straight. And I need to make sure I go through that. So A to B, it is straight, and then it curves. Let's go for some contrast here. It is straight up to B, and then it curves. I don't know, it's going to, and then straight from C to D, and then it curves. It's basically a symmetry here. So farthest it goes in the positive direction is E, that matches. It is straight from C to D, and F to G, it is curved in between there. At G, it has some negative slope, but it becomes less negative. H to I, it is flatlined. Then I to J, my slope is negative and then becomes less so. Something like that. And H just has it coming. All right, any issues now that you're seeing? So. And that probably, so the next to last problem will be this, and then that will be the last part. This part will be worth more than that part. All right, questions? All right, back to the cake formulas, which was the last thing that we did on last Thursday. We had derived already that the final velocity is equal to the initial velocity plus acceleration times time. That was the first one we derived. The next one we derived was that the displacement is equal to the initial velocity plus the final velocity divided by 2 times time. I think I did delta t when I did it on Thursday, so yeah, look at your old notes for my justification for delta t and just plain old t.
Yeah, it was delta t.
Yeah. I'm just leaving t for now, because that's the way I roll today. All right, to get the next cape formula, basically what I'm gonna do is I have a formula for VF here, so I'm gonna plug that in for VF here. So my displacement is equal to VI plus AT, all over 2 times time. I'm doing some addition there, so I got 2 VI plus AT over 2 times time. I can simplify that, or actually, this is basically, I'm dividing this numerator by 2. So that becomes VI plus 1/2 AT times time. So what I have in parentheses there is just the fraction. And then I distribute the time. So I end up with VI times time plus 1/2 AT squared. Go ahead and put the delta x back over on this side. And there we have the third one. And now the fourth one. Something you've been dreaming about for 2 days now, or for a week. Dot products. I think I just briefly mentioned dot products before. I didn't do much with them, right? I'm getting blank stares. All right, dot products. We talked about addition of vectors, subtraction of vectors. Multiplication of vectors, there's 2 types, dot products and cross products. Looking for some look of recognition here. Maybe that was a different class. So if I have A dot B, so I have vector A here and vector B here, with an angle between them. What I'm actually doing is I'm multiplying common, the ones that are in the same direction. In other words, how much of A is in the direction of B? So I'm going to break A up into its components. And I know we definitely did some of that vector stuff, breaking something into its components. That is a right angle. I know if this A is my hypotenuse, whatever I'm breaking up is the hypotenuse. And so this becomes A times the sine of theta, and this is A times the cosine of theta. If you need me to reorient it, I'm just going to rotate that triangle there, and I basically have a hypotenuse of A, an angle of theta, so took that and just tilted. This is A sine theta is the opposite, and A cosine theta, the adjacent. And then I multiply the parts that are in the same direction. Well, B is in the same direction as A cosine theta, not A sine theta, so I don't care about A sine theta right now. So A dot B is A cosine theta times B, which is just A B cosine theta. Suppose instead, draw my A here, draw my B, got an angle of theta between them. Suppose I didn't want to break up A, I want to break up B instead. Well, let's take a look at B. So I've got some part that is parallel to A, and a part that is perpendicular to A. My hypotenuse is b. So my adjacent side here is b times the cosine of theta. My opposite side here is b times the sine of theta. And then I multiply the parts that are in the same direction. So here, if I did a dot b, or b dot a, whichever one I want, it's a times b cosine theta. So just multiplying the parts of the vectors that are in the same direction, which is a b cosine theta. Doesn't matter which one to break up. Doesn't matter the order. A dot b and b dot a are the same thing. So one thing to know about dot products. One, it produces a scalar answer. It's also known as a scalar product because my answer is not a vector. So dot product is the same thing as a scalar product. Or more generalized, it's also called an inner product. I will flip back and forth between calling it a dot product and a scalar product. The other thing, which we can pull straight from this, is if I do a vector dot product with itself, hopefully a little less distorted. Well, it's the magnitude of one of them times the magnitude of the other one times the cosine of the angle between them. What is the angle between a vector and itself?
180.
Ooh, by the way, a vector and itself, it's the angle between them. 0, yes. Now, because I heard 0 here, that I assume you meant radians. There's someone over here I heard. If you were in degrees, it'd also be 0 degrees. Anyway, what is the cosine of 0 or 0 degrees?
1.
Yep. So this just becomes a squared. So any vector dot product with itself is just the magnitude squared. And that's what you need to know for deriving the fourth one. Dot products, when we get to the energy work chapter, we will go into more detail on dot products. But for what we're doing right now, this is sufficient. Questions before we derive the fourth one? I know that displacement is the initial velocity plus the final velocity divided by 2 times time. I know that acceleration is the final velocity minus the initial velocity divided by time. Basically the second step when we derive the first escape formula here. I'm going to multiply the left-hand sides, I'm going to multiply the right-hand sides. I have to multiply them the same way, so we'll do dot product for both sides. So I have A dot delta x equals VF minus VI over T dot VI plus VF over 2 times time. That's just the acceleration and displacement. Again, we're assuming constant acceleration. Although what we're deriving has got a little bit more flexibility than that. The scalar pieces of it, the time and the 2, I can just factor those out. I can just pull them out. There's no special thing with multiplying by scalars. Time, matter of fact, cancels out because I have time in the denominator, time in the numerator. So time is going to go away. The 2, I'm just going to multiply both sides by 2 just to get rid of the fraction bit. So I have 2 times A dot delta x is equal to VF minus VI dot product. And I'm going to I got VI plus VF, I'm just going to switch the order around because you can commute them. VF plus VI. I'm assuming the math people have not lied to me that commutative property of addition holds. And now I've got two binomials. Flashback to algebra 1 or pre-algebra, whenever you first multiply binomials. So I have VF dot VF first, outer, plus VF dot VI, minus the inner, VI dot VF, minus, now last, VI dot VI. So just doing FOIL. So let's take care of part of this. I have VF dot VI minus VI dot VF. What does that equal to?
0.
Yep, because it doesn't matter the order in which I'm doing the dot product. Those will cancel out. Whatever it is, they'll cancel out. I have VF dot VF. What is it?
VF squared.
Yep, and the vector symbol goes away. Minus
VI squared.
and that's equal to 2 A dot delta X. And then to put it into the usual form, VF squared, adding VI squared to both sides, is equal to VI squared plus 2 A dot delta X. Or S or R or Y, whatever one you're using for position. And that's the fourth one. I can do a quick check, just because I can never remember which textbook does what. Somewhere there's an end to chapter 2. Oh, that's chapter 3 there. Somewhere there's a beginning to. Chapter 3. And your textbook only does 4 of them. Okay. We'll leave it at that. Ooh. All right, so next time, well, we got lab on Tuesday, so don't forget to print out the lab. Then we will actually apply this stuff. Probably we'll derive these a different way, also using graphs, just to look at those relationships. The master set for chapter 2, you probably can begin on that. Well, that whole problem with the plus minus 0, there is a problem on the master set for chapter 2. So if you go under coursework, chapter 2, somewhere down, I think it's near the bottom of it, there should be a document that says master set. That is something that will eventually be handed in. I haven't assigned the due date yet because we're not finished with chapter 2. But I do recommend that you start looking at that and doing what you can do. Have a wonderful weekend. Be safe. We set a new record yesterday in coronavirus deaths. Please do not be among them. Stay safe.
You said it's under coursework, and then it should just be master set under coursework.
It should be under coursework chapter 2, and then somewhere near the bottom is master set.
And is there only one of them?
For chapter, I didn't have one for chapter 1, but there is one for chapter 2. I think most of the rest of the chapters will have one. How to do? Oh. Alright, so the Vernier path work, so the distance that edge to that edge should be the same as from this edge to that edge, it should be the same as that. So first you see where the 0 lines up. So that's between, it's like, just past 86. And then you see which of these lines down here lines up best with something right above it. Probably, all right, so then it'd be 86.10. You want more than that?
I guess I hope to ensure that it's not reasonable, because I figured out
Oh, yeah. Your drawing's even worse. So you had 18.44. Well, first off, it's gonna, the last digit is gonna be a 5 or a 0. So,
I do have an image on my phone that I can pull up if that's helpful.
so you want the top scale. Yeah, so using the top scale. Not the bottom one, 0 here. So that 0 is between, that's 4 there, 4.5. Looks like it's just before 4.7. So it would be 4.7, and then you'll look to see which of these lines up best. And you'll probably have to look at the picture on your phone to figure out what that is, but it's gonna
Let
be
me get that.
4.7 something.
4.7.
Yes, Ariana?
Okay, I'm super confused on this whole thing with the graphs.
Okay, creating the graph?
Yeah, like with the velocity, I just don't see what it matches.
Do I still have it up? Okay. So velocity, all right, so it's matching, you have positive velocity up until E. So my velocity is above the axis up until E.
Right.
All right, and then it's 0, then it's negative until you get to J. Okay. All right, so at least from the quick sketch, it matches that in fact that it's positive here, it's negative here.
Okay,
Then,
like why did you take them down and like cast it and then?
all right, so when acceleration is 0, acceleration, this is the slope of that. So if acceleration is 0, I'm saying that the slope of this is 0. So the slope is 0, so that's why that's flat, flat. Wherever acceleration is 0, my velocity graph needs to be horizontal.
Okay. Yeah,
Okay.
so I was confused. Thank you.
Yep. All right, Madison?
Okay, so that's the index, that's where it begins. And so I thought that was like the closest, like with the picture.
Yeah, except we're on the top scale.
Okay,
So that's between 4.6 and 4.7. And then you look at which of these lines up best.
which of those
With,
lines?
lines up best with a line right below it.
Oh, so like this.
You
line
ignore
here.
those completely.
Okay. So. Great. Oh, do you mean with these ones?
Yeah, which of
Okay.
these lines lines up best with one of those lines?
Okay. So that would be right here.
Okay, so that one right there? All right, so that would be, that was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay. So 0, 1, 2, 3, 4, 5, 6, you said that one, or the one next to it?
I said like.
The one next to it, or before it? Or let's just say that it's that one right there, that lines up best with it, the line right above the 6 there.
Sure.
So it was 4.6, and then, so 4.6, and then the next two decimal places, I think that was 5, or 5.5. So it'd be 4.655 centimeters.
Oh. Okay.
Somewhere we've got one that's centimeter wide.
That's just all the time completely like ignore bottom ones because
Well, it's wherever,
Just for this, because,
because this one is metric on the bottom, you ignore the top. That one happened to be metric on top,
right.
and some of these are metric on top. And some are metric on, I think most are metric on the bottom. But some are metric on top and some of them are
Yeah,
centimeters,
I think that's where
centimeters.
the confusion was coming in, because I had, watched a video where it's not.
Yeah, and when I want to find it, it does not want to appear. At least that's metric on top.
Right.
I feel pretty sure there's a centimeter one in here somewhere, but it's not coming at the moment. Oh, on the analysis question.
I can,
Your reasoning was accurate, but you ignored a case of